So let's do some little more sophisticated simultaneous equation solving. And we are going to once again connect this directly to your economic knowledge from introductory microeconomics. This is going to be our first real step into firm theory. Firm theory, of course, we've explored markets, that supply and demand. Firm theory is what is essentially behind that supply curve. These are the firms that produce the output Q. We have to remember there are different firm types, but they basically break down into two general categories, or industry types, should I say, but they basically break down into two different categories. Perfect competition or imperfect competition. Now, some textbooks use the word pure, so they would say pure competition versus impure competition, but I use those terms interchangeably. Mostly I use the word perfect. So perfect competition versus imperfect competition. Now, the difference between the two is that perfectly competitive firms produce a homogeneous product. In other words, they produce identical products across firms, and that makes them price takers in the market. So they take the market prices given and produces out as much output as they like at that price level, and they can sell it all because they're all very small relative to the industry size. Now, imperfectly competitive firms may or may not be small relative to the industry size. In fact, they could be as small as your local Burger King, or they could be as large as a monopoly, a pure monopoly, which is just one firm. But the difference is that in order for those firms to sell more, they have to lower the price of the product. In other words, they face a downward sloping demand curve that has some relative inelasticity to it, versus a perfectly competitive firm which faces a horizontal demand curve. In other words, a demand curve that is perfectly elastic. So I hope all that is coming back to you. If not, go back and revisit that material. Anyway, let's move forward with a very simple model of a perfectly competitive firm. Now, in this case, price is going to equal 10. We know we're working in the world of perfect competition because price is constant here, okay? If you remember before, we had inverse demand functions. Well, that means you're working in imperfect competition if that demand function was at the firm level, okay? Even though we explored it at the market level. If you assume that demand curve is at the firm level, so for instance, with a monopoly or something like that, in other words, where market demand is the demand the firm faces, then you would actually have a downward sloping demand curve. But in this case, we know we're working in the perfectly competitive world because price is constant. Let's assume that total cost equals Q squared plus 2Q plus 1. And let's assume marginal cost equals 2Q plus 2. Now, one thing we have to recognize here is what is this total cost function? Now, if you remember back in introductory microeconomics, total cost equals total variable cost plus total fixed cost. So part of this equation is variable cost, part of it is fixed cost, okay? And we'll get to that in just a minute. What I want you to do is I want you to find the profit maximizing max profit Q star, okay, for this firm, okay. I want you to graph, okay, graph demand, graph marginal revenue, graph price, graph marginal cost, and graph average variable cost. Also graph, make sure you clearly label everything, of course, and also graph Q star F and the area of total revenue. Okay, so we're going to do all this with just this little bit of information. Okay, if we remember, go back to your introductory microeconomics textbook. This is where I'm going to put dollars on the vertical axis because we have costs in here as well. So the dollars represent both prices and costs. Now, if you remember back in your introductory microeconomics textbooks, when the price is constant, okay, for a perfectly competitive firm, it is also equal to the demand that that firm faces. In other words, we can graph demand and price all on the same graph, all on the same curve. Okay, that's price, and that's equals the demand the firm faces. Now, what's also good, when the price is constant, that means marginal revenue must also be constant and equal to the price level. All this we learned back in introductory microeconomics. So we've done the first three. Now we need to finish up by graphing each of these. Okay, so what does marginal cost look like? Well, this is marginal cost. Let's graph this. When Q is 0, what is marginal cost? Well, marginal cost is measured on this axis. So when Q is 0, marginal cost is 2, and it's got a positive slope. So that's marginal cost. Now, we've done that, okay? Now there's average variable cost, and this is where this comes into play, okay? What part of this equation is variable cost and what part is fixed cost? Well, if we remember, the definition of variable cost is a cost that is a function of Q. Definition of fixed cost is a cost that is not a function of Q. In other words, that is my total variable cost. That is my total fixed cost, okay? So my total variable cost equals Q squared plus 2Q. What does average variable cost equal? It equals total variable cost divided by Q. So average variable cost then equals Q plus 2. Okay? So when Q is 0, average variable cost is 2. It's the same as marginal cost. But what's different here? Marginal cost had a slope of 2. Average variable cost has a slope of 1. In other words, average variable cost is simply not as steep as marginal cost is. Okay? But it starts at the same intersection, at the same intercept. So now we've graphed average variable cost. What about Q star F? Well, that's the profit maximizing output level. And if we remember our profit maximizing condition from introductory microeconomics, that is marginal revenue equals marginal cost. Well, marginal revenue in this case is equal to demand and price, which is 10. Marginal cost is this equation here, 2Q plus 2. Okay? So this is where I'm going to find my profit maximizing output level. We solve for Q, that's 2 equals 8, or Q equals 4. Okay? So that is that intersection right there. That's marginal revenue and marginal cost. And Q star F equals 4. Okay? Now, so we've done that. Question is now, what is our total revenue? Okay? Total revenue in this case, or in every case, is P times Q, right? Well, this is P, which is 10. Q is 4. That's my total revenue. And what is it equal to? It's equal to 40. Okay? Now look, I'm going to go one step further here. I'm also going to calculate my profit at Q star F. Okay, and what is profit at Q star F? Well, it's going to be my total revenue minus, which is 40, minus my total cost. Now this is my total cost. So that will be minus Q squared, which is 40 squared. Let me put an extra bracket around here. Plus 2 times 40 plus 1. And that is my total cost. So what is my profit? Well, it's my total revenue, 40, minus my total cost, which is 40 squared, which is oh, you know what I did? Wait a second. Hold on a second. I messed up. Sorry. It is not this. It just dawned on me. Yes, it's revenue minus total cost, but Q is not 40. Q is 4. So let's correct that. Sorry about that. So profit is 40 minus total cost, which is 4 squared plus 2 times 4, not 40, plus 1. I'm an idiot sometimes. Anyway, forgive me. So what is profit? Well, it is 40 minus 16 minus 8 minus 1. Okay, distributing that minus sign all the way through. So profit is 40 minus 16. Well, let's go ahead and add this up. So that is 40 minus 16 minus 8 minus 1. 15. So profit is 15. Okay? So this is a very simple example of graphing firm theory. Okay? When we get into later sections of these videos, we're actually going to be graphing average variable cost functions and marginal cost functions that are nonlinear. Gets very sophisticated at that point. So make sure you go over this really well and understand what you're doing. Let's do one more that's even more complicated. Let's assume we have an imperfectly competitive firm. So let's assume we have inverse demand, which is P equals 7 minus 2Q. Okay. We are going to say that our total cost equation is 2 times Q squared plus 3Q plus 2. Okay, now we're also going to say our marginal cost, which in later videos you'll be able to calculate, but we just don't have that knowledge right yet. But we'll go ahead in later videos. You'll be calculating this. In this video, I'll just give it to you, which is 4Q plus 3. Now, let's go ahead and do the same thing so that we did last time. So graph demand, price, marginal revenue, AVC, MC, Q star F, profit maximizing level of output for the firm, and let's graph total revenue. And am I missing anything here? No. Total revenue And let's calculate profit. Okay, pi. As I think I said in a previous video, pi is commonly used as notation for profit. So we know we have to get to AVC, so let's go ahead and calculate that now. So total variable cost then equals the portion of the total cost function that is a function of Q. So that would be 2Q squared plus 3Q. So then AVC equals 2Q plus 3. Okay? So now we're well on our way to graphing what we have. First, let's graph demand. Well, we have inverse demand here, so we can do that right off the bat. When Q is 0, P is 7. So you notice demand's no longer constant, right? The price is no longer constant. When P is 0, Q is 7 halves. Okay, so that's demand. Done. But guess what? We can't calculate our price yet, and you'll see why in a minute. Can we graph a marginal revenue function? Yes, we can, but this is where we have to rely on our knowledge of basic economics and basic firm theory from introductory microeconomics. Marginal revenue is the change in total revenue from the production and sale of one more unit. Well, at the first unit, it's going to be equal to whatever the price is. That makes perfect sense. However, if we remember correctly, there's something unique about that marginal revenue curve for imperfectly competitive industries, and that is that it splits the horizontal axis between the origin and the horizontal intercept, the Q-intercept. And the reason it does is because that is where demand is unit elastic. If we remember, it's where marginal revenue equals 0 that total revenue is maximized, and that occurs where demand is unit elastic, and that is at the midpoint of the demand curve. If we wanted to back out the function of this, we could, and we could do it very easily. Why? Because this is inverse demand. Okay? You see that this inverse demand curve, or should I say the demand curve, has a slope of, -2. So rise over run is -2. You run 1, you go up 2. You run 1 in the left to the negative direction, you go up 2. Okay? The marginal revenue curve is twice as steep. It splits the middle between the Q-intercept and the origin. So by definition, it's twice as steep. So guess what? If inverse demand is P equals 7 minus 2Q, then marginal revenue must equal 7 minus 4Q. Okay? But we weren't asked to get that. But that's just out of curiosity's sake. If we wanted to back out what the marginal revenue curve looks like, this is the way we would do it. And that intersection there would be 7/4, right? Which is 1/2 7/2. Make sense? Okay. Anyway, let's move on. So that's marginal revenue. Now let's graph average variable cost. When Q is 0, average variable cost is 3. Okay, and it's got a positive slope. Now let's graph marginal cost. Marginal cost. When Q is 0, marginal cost is 3. Just like it was in the last example, but Again, notice here, the slope of average variable cost is 1/2 that the slope of marginal cost. So marginal cost is twice as steep. Let me get this out of here, kind of clean it up a little bit. Okay. So we've done marginal cost. Now let's find the profit maximizing output level. The profit maximizing output level again is going to be found by satisfying the profit maximizing condition, marginal revenue equals marginal cost. So we now have a marginal revenue function which is 7 minus 4Q, and we can set that equal to the marginal cost function, which is 4Q plus 3 equals 7 minus 4Q. So this gives us a Q equals 4, or Q equals 1/2, and that is our Q star F. So this intersection right here is Q star F equals 1/2. Okay, now that settles that. So now we can go back and look at our price. What is our price? Well, we would take that Q and plug it into our inverse demand function. And the reason is because remember from introductory microeconomics, an imperfectly competitive firm, because the price is, or excuse me, because the marginal revenue curve lies below the demand curve, they're going to be able to charge a price that's above marginal cost. That price is going to be equal to the marginal benefit at that Q, okay? And of course we know demand is equivalent to marginal benefit. Again, go back and review Econ 200 if you're unfamiliar with that concept. So in other words, this firm is able to charge a price, the price that they can get for the product, which is equal to the marginal benefit of that unit. Okay, so that is going to be the price up at the demand curve. How do we calculate that? We take that Q, which is equal to 1/2, and we plug it into the inverse demand. So that's P equals 7 minus 2 times 1/2 equals 7 minus 1 equals 6. So P star F, the price the firm charges, is equal to 6. Done. What is the total revenue of this product? The total revenue generated from this product? Well, obviously it's 6 times 1/2, so it's going to be equal to 3, or it's going to be equal to that rectangle there. That's going to be total revenue equal to 3. Okay, 6 times 1/2. Done. What is profit? Profit will be 3, which is total revenue, minus total cost. Total cost, again, is this function up here. So that will be minus 2 times 1/2 squared plus 3 times 1/2 plus 2. So that equals 3 minus 1/2 squared is 1/4. So that's 1/2. Okay, 2 times 1/4 is 1/2 plus 3 halves plus, and since I have to find a common denominator, let me go ahead and just make that into 4 halves, and that way I've got a common denominator already. So that equals 3 minus 1 plus 3 is 4, plus 4 is 8, 8 halves. So that equals 3 minus 4. Let's see, 3 halves, 3. I'm just recalculating this to be if it's correct. I believe that's correct. Yeah, I believe that's correct. So that equals -1, okay? So in this case, the firm is making a negative profit. I hope that's clear enough. Again, this is a far more complicated model. So go through it. Go through it over and over again. Don't just do it once. Go through it over and over again. Make sure you can